A very good afternoon to all the participants, speakers, and sponsors of the 22nd MECB conference. I'm Mani Megale Victoria, and I'll be moderating the second industrial lecture sponsored by Siemens Healthineers Malaysia. A friendly reminder that anyone with questions is welcome to write them into the Q&A box, and also kindly fill up the feedback form after the session. Dr. Kamal Modi from Lal Pets Lab in India will speak to us today on a digital transformation of laboratory medicine. Dr. Kamal has been employed with Dr. Lal Pet Labs since 2018 as a senior consultant biochemist for clinical chemistry and biochemical genetics. He is in charge of company's research, evaluation, and validation of frontline technologies and assays. Dr. Kamal also spent 3 years at SM Gene Lab as a research scientist for cytogenetics. I welcome Dr. Kamal as he begins his talk. The screen is yours, Dr. Kamal.
Hello, everyone. And in this conference, today we are discussing about the digitalization and automation. I am Dr. Kamal Modi, working with the Dr. Lal Pet Labs since 2018 and as a senior consultant biochemist for the biochemistry and immunoassay section. And here, my primary role to look out for these testings. So, what is digitalization and automation? As what is total lab automation? Like there are two parts. One is action automation and a decision automation. In action automation, we can say there are track automation where we can say conveyor belt is there are certain other modules. Then there are pre and post analytical modules in which helicopter is there, rack input module is there, and certification is there. While there are analytical automations where actual machines like chemistry analyzer and immunoassay analyzers are there. So all are having robotics arm. So technicians need not to go to the machine and put the samples within. They just put the samples on the rack input module, and accordingly they will carry through the track. But which by which process, or we can say by which informatics it is going through the track to the analyzer, and diagnostic IT play part into this process And middleware is very useful, and we can say heart of this entire track system, where it can help and command the particular sample to go through the machine from the input modules, right? So we can say total lab automation is the use of robots to automate highly repetitive routine tasks normally performed by knowledge workers, coupled with application of digital intelligence to the data sets generated during workflow. And these data sets generated during workflow are actually evaluated with the help of process manager and tools accordingly. Then go to the so how digitalization are completely occurring in our lab. The use of digitalization is improving business process and provide new value, and which we can discuss with the various case studies that we have encompassing in this um, our presentation, where we can divide this case study into three four parts: pre-analytical, analytical, post-analytical, and real-time operational analytics. So we can go through the first case study, where we are discussing about the aliquoting logic. So conventionally, what is happening is, as a reference lab, we are getting multiple samples, and one sample can carry multiple tests, which is done in uh, one department or many of the departments. Like they are sharing with the many of the departments, right? So to perform the test in defined time frame and report to the patient, we have to aliquot that sample into various parts. And in that process, we are having around 400 aliquots a day in conventionally. But with the help of decision automation, we have come down this aliquots to 1,000 tubes per day. But yes, we feel there are some scope of reduction into this, and we have built up advanced dynamic aliquoting sorting logic with the help of Siemens team, which can further reduce number of aliquot to less than 400 tubes per day. So what is the logic? For example, if a particular sample is there with the department and having a single test which is not belongs to the track analyzers, right? And it is a sharing with other department, then this logic is built in such a way that this tube primarily shot on the output module rather being aliquoted one. So that is how we have saved our aliquots. Then if there are multiple tastes are there from which are sharing with the other departments and not belong to the track, then the logic will set in a such a way that highest priority aliquot will be shorted as a primary tube, and the other department will have aliquots like one tube which is there for the ANA, TTG, and HIV, right? So the logic will set in such a way that primary tube will be short for ANA department to perform this test, while other department like having to carry this other test, they might be having aliquot like microbiology ELISA section, which have to perform HIV. They will have aliquots, while ANA performing department is having primary tube. So that is how we can reduce the aliquots as well. Then if we are having multiple aliquot tests on the track, like tube is having KFT, thyroid hormones, and along with that, it is also having some HBS antigen also, which is done by other department, not onto the track. Then what is happening with this logic? They will perform the test, whatever that is on the track, and after that, it will be shorted on the output module as a primary tube and not being aliquoted. So these are the very advanced aliquoting logic by which we have reduced our aliquots from 4,000 to 1,000, and now 1,000 to around 400 or less than 400. So this is the like data from May 2020 to May 2021, where we have observed there is drastical reduction of the aliquots as compared to our workloads, and we there is 30% um, that is so aliquot reduction from uh, at only 400 aliquot contributing only 2% to 3% of the sample, which is previously 10% of the aliquots. So, what is the extra benefit from this aliquot reduction? Now, reduction in aliquot help to improve sample availability between department, and that will reduce the errors, mainly quantity not sufficient, because department is not getting enough volume to carry out the test. And this error is drastically reduced. As you can see in this graph, there is 30% reduction we have observed in QNS data in our department only. So it will help in reduction of human effort, cost, and errors. As you can see, this is come down from 10% to the 2% right now in the aliquot. And by this, looking at this, we have published white paper also for in AFCB News 2222. Now we come to the second part of the study, which is in the analytical part, where we are discussing about patient moving averages, right? So what is patient moving average? Patient moving average are running averages of the patient results for specific assay over preset number of data points, and historically have been commonly used in hematology laboratories. With the computing power made available by the data management through the data management systems, PMA are increasingly used in chemistry and immunodiagnostics as an agent to QC process. So, why this PMA is required? Basically, all laboratories are performing QC processes, like quality control process, and but at several hours of intervals. But if error occurs between this interval, how one can find out that if is there any systemic error occurs or not? And in that, we can have a chance to wrong reporting. So PMA will give us that benefit of early detection of systemic error in between that QC events. As this process is continuous, and shift and change can be detected before errors are detected by successive QC events, right? So PMA can detect systemic error in assay performance attributable to the specific region lot or issues with specific region container. Saves cost and effort as no additional QC material or reagent needed. There is no need to perform additional tests. The use of PMA qualifies the regulatory requirement or for the auto verification as well. So how it works and what are the types of PMA? There are two types of patient moving average. One we can call audit or undefined PMA, and other is defined PMA. To start with any data, like we have to set in certain prerequisites. One, that is bean size, and then truncation limit. Like we are setting our TSH, where we can say that suppose 1 to 150 is the range we can allow to build in this data for the TSH, right? So over a period of time, this data will be cumulated. As you can see, mean, SD, and CV will be calculated, and in the undefined manner. Like it is a passive continuous monitoring, and the PMA are calculated and presented as you can see in this box, but no rules or limits are defined and no alerts are triggered. So it is the first initial an essential step in using PMA in order to develop understanding of how PMA trend. After we have enough data, then we can set our target mean and SD. And now this process is called defined PMA, where we can set our target value, target deviation, bin size, and truncation limits is already set in. Now, with the target value and deviation, we can set our defined limits, and rules can be set. So QC alerts are triggered and results held based on defined limits and rules. So many laboratories use a combination of audit and defined PMA depending on the assay. As you can see, this is like our LJ, conventional LJ that we are seeing in quality control process. If there is any outlier, it will give you an alert and you can take specific action onto that. So let me see one of the examples for this. We have an alert on one particular day like this. You can see the alert on the QC chart of the homepage of Atalica Data Manager. So we have clicked on this where we have find out we are having alert for the T4, total T4, right? Where we have observed the results, the mean of the this bean, particular bean is having on the negative side for two successive batch, and results are getting held as we have discussed because the mean is set and we are having an outlier. So all the results are being held in which are processed in this particular bin. As we can see, all are the results are uploaded except for the T4, correct, which is being held for review. After taking corrective action, the result can be uploaded. So it will give you a time and also it will help in releasing, not releasing the wrong reports. So this is the LJ, that is before taking corrective action, and after taking corrective action, we can monitor also that our process is now in tune with our successive data. So there is one more example that we have come to know in real time basis. One particular day we are having an outlier on the positive side with the iron. Like you can see, we have set the target value for iron is 61, while the mean of this data is having 139 and 142, which is almost double to our target mean. So we have find something fishy is going on, and but these all results are held, and we are fortunate enough to get the time. So we have rerun all these samples on the another machine and stop this machine to process other tests. While we observing the data, we have find out that many of the results are having certain errors, like more than 1,000 results are getting in more number of times. So all the results are on higher side. We have run QC as well to find out is there any error it is there, and similar event we have found in our QC as well. Then we have checked reagent where we have find out a clumping at the bottom of the reagent. So we come to know that reagent is faulty and that is why there is error in the results. But with the help of patient moving average and alert, we have saved at least 100 results to go with the patients and taking corrective action before releasing the reports. So that is how it will help. Now, the adding benefit, we can say that due to patient moving average, we have increased our confidence limit for certain of the parameters. And so we have increased our auto verification limit accordingly. For the lipid profile, we have increased our confidence limit. So cholesterol, triglyceride, HDL, LDL, all our value are getting auto verified with the higher auto verification limit, and that will lead to increase in our auto verification rate. Right now, we have implemented the same process with the KFT parameters and LFT parameters as well. And the data is now having that we have observed. We are getting 75 or to 76% of the reports are being auto verified with the help of patient moving average only. So for the same, with the same data, we have published another white paper in the AFP-FCB News 2021 for the patient moving average. Then there are certain other processes where manual intervention needed conventionally. But with the total lab automation, we have certain other, we can say, points where we can work upon. So auto verification based on CLSI guideline, there are certain checkpoints where we have to work on. Like there is some recheck criteria should be set in for the lab. AMR should be defined, instrument flag should be defined, and you should take corrective action on that flags. Then HL should be defined. So all this functionality can be done with the decision automation. We have set in the rules in Atelica Data Manager itself. So we don't have to just review the results, and after that we have to recheck. It will auto reruns, and there will be auto diluted rules are there. There are auto hold of result if there is a value which is less than or more than AMR. If there is instrument flag, the results automatically hold onto that machines and will not transfer to the limbs where we are validating the results. If there are hemolysis index outlier, then results will be held at the ADM level and for the review. And after that, we can take a corrective action. So all this functionality are there in this. uh, we can achieve with the decision automation. So after that, we can go through the other case studies like um, continuous onboard inventory management with the help of Atelica Process Manager. Atelica Process Manager is the tool where we can have many of the functionality, like we can check real-time inventory, then we can check our data for the automation utilization, throughput, and turnaround time on the track. So these are the tools which are available with the APM. At the time of COVID, we have certainly this software is certainly very useful. Like during peak of COVID, there is sudden change in taste mix of sample being processed. Digitalization provided the visibility of taste mix arriving the samples, which helped to plan the day with full visibility and remote monitoring of onboard reagents and consumables. Extremely high sample load was processed without any significant disruption. Let me explain. Like you will see, this is the automation utilization tool homepage, where we can see we are having um, certainly drop in the automation utilization in the form of throughput in the peak hour of our testing. So we have analyzed the data why there is a drop, where is the drop in that particular timings. So if we conventionally we can see that with this tool, this is our taste mix where we can see TSH and LFT, KFT parameters are much more in numbers compared to other ones. But at the time of COVID, we are getting requests for the CRP, ferritin, and LDH, which is completely opposite to our normal routine. Due to that, we are having certain issue with our inventory management, and our machines are getting exhausted with the inventory for the CRP, and that is why this drop in the utilization occurs, because machine has to sample has to wait for replenishment of this inventory, and after that testing can proceed. So after looking at this data, we have changed our plan of strategy, and we have with the help of in real-time inventory, we come to know that the CRP level of that particular machine is what is the inventory number, right? Like, sorry, uh, like we can see here, if there is, we have set the rules in the inventory management, and if it will give us alarm whenever there is low inventory for the CRP. So the staff is vigilant enough to see that CRP inventory on the Entalica Process Manager tool, and they will replenish the CRP inventory on particular machine after getting that alert, and thereby we have reduced the chances of exhausting the reagent. And that is how we have managing our throughput all of the day in the COVID days. Like you can see, there is a balanced throughput and utilization across the day after that exercise. This is another day where we can see balanced utilization. So this is the screen where we can monitor our regions, and that will give you information how many tastes is remaining, and what is the lot is which lot of reagent is going on, the expected onboard stability, all the information are there, and you can review it by sitting at your desk only, not going for the to the machine in front of the machines. So this is the facility by which we have improved our on-time reporting as well. Because with this facility, we now reducing our many of the errors, and there are certain checkpoints that we have already discussed, like recheck criteria is automatically done, then rerun criteria are set in, dilution criteria set in. So this is all small steps will lead to increase in our on-time reporting with the total digitalization that is up to 92.3%, which is conventionally around 84-80% without this digitalization. And SD is also reduced from 6 or 8 to now 3.2%. So that from this we have started our journey. Like there are scattered island of instruments, and there are multiple touch points for the technicians as well. They have to run to the various part of the instrument area and process the taste. But with the help of digitalization, now there is very only two touch points where we can load the sample and unload the sample. Otherwise, the touch point has reduced, and the time is also reduced. So digitalization, we can say, in COVID is the helpful tool. And in COVID-19, the wave in India witnessed this unprecedented volume of tube or samples arriving, while there are significant lesser staff reporting to the work. So with the less staff, we have achieved to finish that work. Under such circumstances, digitalization and digital resources help considerably in amplifying the capability of existing resources as below, that in terms of patient moving averages and auto verification of the results, real-time monitoring and managing optimal onboard inventory levels, intelligent aliquoting logic, and this all help enhance the efficiency of our workflow within the lab while also serving the patient with faster and better outcome. We believe that there is a more to achieve, and we continue to move forward in this fascinating journey. So yeah, this is all from my side. Thank you.
Many thanks to Dr. Kamal for his insightful and very comprehensive presentation. Kindly fill up the feedback form appeared on your screen. Next, we have a lunch break till 2 p.m. In the meanwhile, you are all cordially welcome to visit the booth and view the posters. Before I wrap up this session, let's watch a short commercial video by BD Becton Dickinson. Thank you very much in advance, BD. We will see you at the MSCB Young Scientist presentation. Good day for now.
I was there when one man's love for his ailing wife created a product that changed the course of medicine. I was there when we learned he was going to have a little sister. I was there when we learned there was more time. I was there when neighbors became lifelines. I was there for discoveries and the diagnosis, for life-changing personal moments and major medical breakthroughs, with global presence and impact, making a difference far beyond lab walls and the medical community. For 70 years, we've set the standard for safety, diagnostic accuracy, and patient comfort. And we're just getting started.